Hi dear students, in this video also we are discussing the questions from JEE-MAIN 2024 entrance examinations from the chapter Electrochemistry. These questions are mainly from the topics electrode potential, NERNST equation, commercial cells, product of electrolysis, etc. Question number 1. One of the commonly used electrode is calomel electrode. Under which of the following categories calomel electrode comes? First option is metal insoluble salt anion electrodes. Second option is oxidation reduction electrodes. Third option is gas ion electrodes. Fourth option is metal ion metal electrodes. We know calomel electrode is a secondary reference electrode. Reference electrodes are the electrodes used for determining the electrode potential of half cells. Calomel electrode consists of mercury in contact with mercurous chloride, that is Hg2Cl2, which is also known as calomel, and a saturated solution of potassium chloride. It is represented as mercury Hg bar Hg2Cl2, which is an insoluble salt, bar potassium chloride KCl in bracket saturated. So calomel electrode is a metal insoluble salt anion electrode. So here the answer is option number 1. Then question number 2. The reaction at cathode in the cells commonly used in clocks involves option number 1, reduction of manganese from +4 to +3. Second option, oxidation of manganese from +3 to +4. Third option, reduction of manganese from +7 to +2. And the fourth option, oxidation of manganese from +2 to +7. We know the cells which are commonly used in clocks are dry cell. In dry cell, anode is a zinc container, while cathode is a graphite rod surrounded by manganese dioxide MnO2 and carbon. The electrode reactions are at anode, zinc container get oxidized to Zn2+ by the release of 2 moles of electrons, while at cathode MnO2 combines with NH4+ and the electron to form MnOOH plus NH3. That means at cathode MnO2 is converted into MnOOH. That is, the oxidation number of manganese is reduced from +4 to +3. So here the answer is option number 1. Then question number 3. For the electrochemical cell M bar M2+, double bar X bar X2-, if E0 M2+ bar M is equal to 0.46 volt and E0 X bar X2- is equal to 0.34 volt, which of the following is correct? Option number 1, E cell is equal to -0.8 volt. Second option, M plus X gives M2++ X2- is a spontaneous reaction. Third option, M2+ plus X2- gives M plus X is a spontaneous reaction. Option number 4, E cell is equal to +0.8 volt. For the given electrochemical cell, first of all, we can calculate standard EMF of the cell. That is, E0 cell is equal to E0 cathode minus E0 anode. Here E0 cathode and E0 anode are given. Therefore, E0 cell is equal to 0.34 minus 0.46, that is equal to -0.12 volt. That means E0 cell is a negative value. The negative value of E0 cell means the forward reaction is non-spontaneous, only the backward reaction is spontaneous. So here the spontaneous reaction is M2+ plus X2- gives M plus X. So here the answer is option number 3. Then question number 4. A conductivity cell with the 2 electrodes in bracket dark side are half filled with infinitely dilute aqueous solution of a weak electrolyte. If volume is doubled by adding more water at constant temperature, the molar conductivity of the cell will, first option is increase sharply, second option remains the same or cannot be measured accurately, third option decrease sharply, fourth option depend upon the type of electrolyte. In this question, it is given that half of a conductivity cell is filled with an infinitely dilute aqueous solution of a weak electrolyte. In an infinitely dilute aqueous solution, all the ions have independent migration. So further dilution will not affect the conductivity of the cell. So here the answer is option number 2. Now question number 5. How can an electrochemical cell be converted into an electrolytic cell? Option number 1, applying an external opposite potential greater than E0 cell. Option number 2, reversing the flow of ions in salt beds. Option number 3, applying an external opposite potential lower than E0 cell. Option number 4, exchanging the electrodes at anode and cathode. We know if a potential greater than E0 cell is applied to an electrochemical cell, then it will act as electrolytic cell. For example, during the recharging of lead storage cell, it will act as electrolytic cell. So here the answer is option number 1. Question number 6. The metals that are employed in the battery industries are A. Iron, B. Manganese, C. Nickel, D. Chromium, and E. Cadmium. Choose the correct answer from the options given below. First option B, C and E only. Second option A, B, C, D and E. Third option A, B, C and D only. Fourth option B, D and E only. As we know, in commercial cells, manganese is employed in dry cell. Nickel and cadmium are employed in nickel-cadmium storage cell. But iron and chromium are not employed in any of these commercial cells. So here the answer is option number 1. Then question number 7. Reduction potential of ions are given below. First ion is ClO4 minus. Its E0 is equal to 1.19 volt. Second ion is IO4 minus. Its E0 is equal to 1.65 volt. Third ion is BrO4 minus. E0 value is equal to 1.74 volt. The correct order of their oxidizing power is option number 1, ClO4 minus greater than, IO4 minus greater than, BrO4 minus. Second option, BrO4 minus greater than, IO4 minus greater than, ClO4 minus. Third option, BrO4 minus greater than, ClO4 minus greater than, IO4 minus. Fourth option is IO4 minus greater than, BrO4 minus greater than, ClO4 minus. We know a reactant with high reduction potential value undergo reduction easily. So it can act as strong oxidizing agent. Here in this question, BrO4 minus ion has highest reduction potential value, so it is the strongest oxidizing agent. And then IO4 minus and then ClO4 minus. So here the answer is option number 2. Question number 8. Match list 1 with list 2. In list 1, some commercial cells are given. A. Leclanche cell, B. Nickel cadmium cell, C is fuel cell, and D. Mercury cell. In list 2, use, property or reaction of these cells are given. First one is converts energy of combustion into electrical energy. Second one is does not involve any ion in solution and is used in hearing aids. Third one, rechargeable. Fourth one, reaction at anode is Zn gives Zn2 plus 2 electron. Choose the correct answer from the options given below. As we know, in Leclanche cell, anode is zinc, so it matches with 4. That is, the reaction at anode is Zn gives Zn2 plus 2 electron. Nickel cadmium cell, as we know, it is a rechargeable battery, so it matches with 3. In fuel cells, the enthalpy of combustion of fuels like hydrogen, carbon monoxide, methane, propane, etc. are converted into electrical energy. Therefore, it matches with 1. This mercury cell is also called button cell, which is used in compact devices like hearing aids, watches, etc. It does not involve any ion in the cell reaction. So here the answer is option number 3.